Now let us understand the anatomy of breathing organs. When the child is in the mother womb, mother does the breathing. Her lungs delivers oxygen to the uterus and the placenta. From there it travels to the umbilical cord, which takes the oxygenated blood to the liver. The two sides of hearts are connected by passing the lungs, which remains dormant until the child is born. When the child is born, the umbilical cord is severed. The first breath is most important and forceful a human will ever take. The first inhalation must be so forceful because it needs to overcome the initial surface tension of the previously inactive lung tissue. The force required to overcome that tension is 3 or 4 times greater than that of normal inhalation. The initial inhalation of the lungs triggers enormous changes in the circulatory system, which has previously been geared receiving oxygenated blood from the placenta. The first breath causes a massive surge of blood into the lungs and the right and the left side of the heart to separate into two pumps. This is the simplified diagram of the body. The torso consists of two cavities, thoracic and abdominal. Both cavities open at one end to the external environment. The thoracic opens at the top and the abdominal opens at the bottom. The cavity opens to each other by means of an important shared dividing structure, the diaphragm. Another shared property is both the cavities are bound posteriorly by the spine. The two cavities also share the quality of mobility. They can change their shape. The shape changing ability is the most relevant to the breathing. Without this movement, the body cannot breathe at all. The abdominal cavity changes shape like a flexible fluid filled structure, such as a water balloon. When you squeeze one end of the water balloon, the other end bulges. This is because water is uncompressible. Your hand section only moves the fixed volume of water from one region of flexible container to another region. The same principle applies when the movements of breathing compress the abdominal cavity. A squeeze in one region produces a bulge in another region. In breathing, abdominal cavity changes shape but not volume. In contrast to the abdominal cavity, the thoracic cavity changes both shape and volume. It behaves as a flexible gas-filled container. Volume and pressure are inversely related. When volume increases, pressure decreases. And when volume decreases, pressure increases. Because air always flows towards area of lower pressure. Increasing the volume inside the thoracic cavity will decrease the pressure and cause air to flow into it. This is an inhalation. It is important to note that in spite of how it feels, when you inhale, you do not actually pull air into the body. On the contrary, air is pushed into the body by the atmospheric pressure that always surrounds you. This means that the actual force that gets air into the lungs is outside the body. The energy expended in breathing produces a shape that lowers the pressure in the chest cavity and permits the air to be pushed into the body by weight of atmosphere. In other words, you create the space and the universe fills it. During relaxed, quiet breathing, such as while sleeping, an exhalation is a passive reversal of this process. The thoracic cavity and the lung tissue, which have been stretched open during the inhalation, spring back to their initial volume, pushing the air out and returning them to their previous shape. This is referred to as passive recoil. Any reduction in the elasticity of these tissues results in a reduction of body's ability to exhale passively, leading to host of respiratory problems. In breathing patterns that involves active exhaling, such as blowing out candles, speaking, performing various yoga exercises, the musculature surrounding the two cavities contracts in such a way that the abdominal cavity is pushed upward into the thoracic cavity, or the thoracic cavity is pushed downward into the abdominal cavity, or any combination of the two. The lungs occupy a three-dimensional space in the thoracic cavity. When this space changes shape to cause air movement, it changes shape three-dimensionally. Especially in inhalation, involves the chest cavity increasing its volume from top to bottom, from side to side, and from front to back. And an exhalation involves a reduction of volume in those three dimensions. Thoracic shape change is linked to abdominal shape change. You can also say that abdominal cavity also changes shape in three-dimensional. It can be squeezed from top to bottom, from side to side, from front to back. In a living breathing body, thoracic shape changes cannot occur without abdominal shape change. That is why the condition of abdominal region has such an influence on the quality of our breathing. And that's why the quality of our breathing has a powerful effect on the health of our abdominal region. In yoga, the spinal movements are intrinsic component of shape changing activities of cavities. This is why yoga practice involves coordinating the movements of the spine with the process of inhaling and exhaling. It is instructed to inhale during spinal extension and exhale during spinal flexion. The diaphragm is a single muscle capable of producing on its own all of the three-dimensional movements of the breath. It is the principal muscle of breathing. The diaphragm shape is created by the organ. It encloses the and supports. The diaphragm has an asymmetrical double dome shape. The right dome rises higher than the left. The liver pushes up from below the right dome, and the heart pushes down from above the left dome. The diaphragm divides the torso into the thoracic and the abdominal cavities. It is the floor of the thoracic cavity and the roof of the abdominal cavity. The uppermost part reaches the space between the third and the fourth ribs, and its lowest fiber attached to the front of the third and the second lumbar vertebrae, or you can say it's from nipple to navel. The muscular action of diaphragm is most often associated with the bulging movement in the upper abdomen, which is commonly referred to as belly breath or abdominal breath. In this, the base of the ribcage, that is the lower attachment, is stable, and the domes, that is the upper attachment, are mobile. This is one type of diaphragmatic breathing. If we reverse these conditions by stabilizing the upper domes while relaxing the ribcage, a diaphragmatic contraction causes an expansion in the ribcage. This is called chest breath, which many believes to be caused by the action of muscles other than the diaphragm. The mistaken idea creates a false dichotomy between diaphragmatic and so-called non-diaphragmatic breathing. Many people receiving breath training who exhibit chest rather than belly movement are told that they are not using the diaphragm, which is entirely wrong. Except in case of paralysis, the diaphragm is always used for breathing. The real issue is whether or not the diaphragm is able to work efficiently, meaning how well it can coordinate with all other muscles that can affect shape change. Along with respiratory diaphragm, breathing involves the coordinated action of the pelvic and vocal diaphragm. The pelvic diaphragm separates the pelvic cavity above from the perineal region below. In yoga, this is used in Mool Bandh and Udyan Bandh. Vocal diaphragm is glottis, which is not a structure but a space between the vocal cords. This is gateway to the respiratory passage. This space is regulated in various ways depending upon breath, voice and posture. In yoga, while doing breathing exercise such as Kapalbhati, Bhastrika or Ujjayi Pranayam, this vocal diaphragm is used.